today we are talking about degrees and radians. So you know how you had that little button in your calculator that said RAD and I told you to never use it? Okay. In your calculator, you're still not using it. Does that make sense? Okay. But I'm going to teach you today what that RAD stands for, and it stands for radians. So a radian corresponds with an angle measure. So it's kind of a different way to interpret angle measures. Angle measures are typically used in geometry. Radians are what you start to use when you get into pre-calculus and calculus. So it's basically kind of switching our perspective here. So we have different angles in standard position. So when we talk about the standard position of an angle, the first side, which we call the initial side, is always going to be on this positive like x-axis here. So we call this the initial side. And again, it is always the positive x-axis. So that is always going to be our starting point for any of these angles. Okay, and we're typically speaking going to go counterclockwise, okay? And so where our other side of our angle ends up, we call that that was a bad arrow. We call that our terminal side. Okay. And so this entire angle that's formed is typically abbreviated by theta. Again, where theta is representing an angle, that's that Greek word, theta. Okay, so we can have both positive and negative angles. So when we have a positive angle, again, we start on that x-axis for our initial side. And a positive angle is going to be counterclockwise. So when we go this way, that is creating a positive theta. That is counterclockwise. We know what counterclockwise means, yes? And so when we go the other direction, when we go clockwise, that generates a negative theta, or a negative angle, negative theta. I'm sorry? Yes. Okay. So, a radian. So a radian is an angle whose arc length equals the length of the radius. So I'll show you what that means in a second. But 180 degrees is equal to pi radians. Okay. So what does this mean? I'm going to draw a little circle. Nope, that's not a circle. There we go. Okay. Now, let's say I draw this circle and it has a radius of, 2 inches. Okay. So let's say I picked up that radius and I put it along the edge of the circle. Okay. So if I put that along the edge of the circle, the first length that is 2 inches, say like this one, right? This would also be 2 inches. That is 1 radian. Okay, so a radian essentially when we take the radius and we put it around the edges of the circle. Does that make sense? Yes. So let's say I drew another radian. So here's another 2 inches. It's another radian. And I drew one more. Am I really at a semicircle yet? No, not quite. So I have to go a little bit further, right? And what do we think that number is? What's a pi, right? That's a number that's a little bit bigger than 3. Does that make sense? So this is why 180 degrees is equal to pi radians. Because we have 3 radians and then like a little more. Bless you. So, how many radians do we think are going to be in a whole circle? 2 pi. So a semicircle, 180 degrees is pi radians. A whole circle is going to be 2 pi. All right, so we are going to use this to convert between radians and degrees, okay? So we're allowed to do this because 1 degree is pi over 180 radians, and 1 radian is 180 over pi degrees. Again, this is because 180 is equal to pi radians. Okay, so we can use these factors to convert between radians and degrees and vice versa. And we are going to do these without a calculator because we're smart. Okay, nobody seemed really confident in that, but it's going to be great. All right, so we're converting these to radians. So when we are converting these to radians, again, we said 1 degree is equal to pi over 180 radians. So we take the number of degrees, which is 40, and we are going to multiply by pi divided by 180. Okay. So, both 40 and 180 are divisible by what? 4. You can pick it. Let's start with 2. Okay? Because we know they're divisible by 2, right? It doesn't have to be the least common. You could pick 4. They are both divisible by 4 as well. But do you know what 180 divided by 4 is off the top of your head? Yeah, maybe not. Okay, so that's fine. So we'll just divide by 2. So that's 20 and 90. And then those are also divisible by 2, right? So that gives us 10 and 45. And then can I divide those any further? 5, right? So 10 divided by 5 is 2, and 45 divided by 5 is 9. So our radians would be 2 pi over 9.
That's cool.
Okay, so I'm going to draw like a little angle to kind of help us with this. So if a semicircle is pi, yes, we are going 2/9 of that semicircle. Does that make sense? It's a fraction. Yes. 2/9. Okay, so that means that this angle is 2/9 of a semicircle. It's going to look decently small because it's 2/9 of a semicircle. Do you get what I'm saying? No. Okay. You don't need to draw this, but just, this is our semicircle, right? Yes. Now, if I split that semicircle into 9 little pieces, so 1, 2, 3, 4, oh, that was bad, 5, 6, 7, 8, oh, I did not do enough. Let me try again. Okay, so this is 9 sections, yes? Basically what this angle is saying is we're doing 2 of those 9. So that's why this angle looks like this. Yes?
But I thought that 2 pi was like the whole circle.
2 pi is the whole circle, but it's not just 2 pi, it's 2 pi over 9. So it's cutting it up. This is the same thing as 2/9 pi. Do we understand? Guys, it's fractions. I think we're overthinking it a little bit. If a semicircle is pi, we're doing 2/9. Okay? We'll do it again. So let's do it with -60. So we have a -60. Again, we are converting into radians, so we'll multiply by pi over 180. And what are both of these divisible by? They are both divisible by 60. So this is going to be -1, and this would be 3. So we can write this as -1 pi over 3 or just -pi over 3. Okay, so this time we're going clockwise. Does that make sense? And we're going 1/3 of a semicircle. Do we understand that? Yes? Okay. So we're going 1/3 of a semicircle. So that means it's going to be like here-ish, you know, because it's not quite a half. You don't. It didn't ask us to. We're going to later, so I'm trying to get us more practice earlier, if that makes sense. Mm-hmm. All right. Do you want to try number 3? Okay, try number 3. Did you get 3 pi over 2? Okay, so are we going clockwise or counterclockwise? Counterclockwise. And 3 pi over 2 is like 1.5 pi. Do we understand that? So that means we're going a semicircle, and then we're going half of a semicircle more. Does that make sense? So it would end up being here, but we would have gone this direction.
How do you know if it's going what, counterclockwise or clockwise?
If it's positive, it goes counterclockwise. If it's negative, it goes clockwise. All right, let's do the last one. So we have -135, and we are multiplying by pi over 180. So what are both -135 and 180 divisible by? 5. They are. So this will be negative. Do you know what that is?
I don't know, maybe like 18. Probably not.
It's 27. You double it and move the decimal.
I'm sorry.
Yeah, if you're dividing by 5, you can double it and move the decimal. So like 135, if you double that, that's 270.
Will we have a mini calculator?
Yeah, you'll have a mini calculator, I think.
I did to my notebook, so 135
Yeah. I mean, you can do that too. All right, and then 180 divided by 5, again, double it, which is 360, and then move the decimal, so it's 36. Mm-hmm. Yeah, whenever you divide by 5, double it, move the decimal. It's also how you calculate tip. Yeah, because dividing by 5 is 20%, right? So if you have a total on your check, you could double it and move the decimal, and that's 20%.
Oh yeah, that is
I just
good
believe
though.
in whatever.
Just move.
My husband just hands it to me, and then I do it. But If you want a quick trick, double it, move the decimal, and that's about what you should do. Okay. Anyway, are these divisible by anything else?
9.
Yes, they are. So 27 divided by 9, we get negative 3, and then for this we'll get 4. So we have negative 3 pi over 4. So again, clockwise or counterclockwise? Clockwise this time because it's negative. Do we see that? It's like the opposite of what you think. I know. It's clockwise. And again, we're going 3/4 of the way around. Do we understand that? No?
Yeah.
Yes, okay. So we're going 3/4 of a semicircle. So now we're going to go the other direction. All right, can I go? So we're going to practice graphing these in terms of radians just because I want us to get used to it, and then we'll kind of see how it converts to degrees. So 7 pi over 12, that is 7/12. Do we understand that? So that's a little bit more than half, right? Because 6/12 would be half. Do we get that?
Yes.
Okay, so we are going counterclockwise. So that means this is going to be like about here. When we're drawing these angles, I'm looking that we're like in the vicinity, but I'm not going to like, if you draw it a millimeter or two in either direction, I'm not going to like pitch a fit. Okay. I mean, if you draw it like over here, then that's wrong. Do we get that? Okay. Great. So let's convert. So we're going to take 7 pi over 12. And this time, instead of multiplying by pi over 180, we're going to multiply by 180 over pi. Okay. So what's one thing that's definitely going to cancel? The pi's. Okay. So, and then 180 and 12, what are both of those divisible by? They're both divisible by 3. We could start there. 180 divided by 3 is what? 60. And then 12 divided by 3 is 4. Are both of those divisible by the same thing? Mm-hmm. They're both divisible by what? You could go even further. 4. So 60 divided by 4 is 15. And 4 divided by 4 is 1. Right? So really we're doing 7 times 15. And what is that? Do you know? Well, 15 plus 15 is 30, right? So plus another 30, that's, and then another 30, and then a 15. It's 105. And it's divided by 1, so do I really need to put the divided by 1? No. But do you see how if we look at that angle, that's like a little bit more than 90? So it is lining up. So you can kind of check yourself with either measure. All right, can I go to the next one?
Wait, for that last thing, 105, would you just do 7 times 15?
Okay, so I'm doing 7 times 15, right? And like 15 plus 15 is 30.
Yeah.
So it's like 30, 60, 90, and then I need one more. So that's what's getting me to 105.
Got it.
Okay. Yeah. Okay, thanks. All right. So this one, how far are we going clockwise or counterclockwise? Counter, because it's positive. And 11 over 6.
Isn't it just a little bit less than 2 full?
It's slightly less than 2 full, than a whole way around. Does that make sense?
Uh-huh.
Right? Because 12 over 6 would be all the way. So it'll be like here-ish, but we'll have gone this direction. So we have 11 pi over 6. And again, we are multiplying by 180 over pi. So, nice thing, pi's cancel. And 180 and 6 are both divisible by what? 6. So 180 is going to go to 30, and 6 will go to 1. So what is this going to be?
Whatever that is.
11 times 30.
11
330. And again, what's all the way around the circle in degrees? 360. And so this is really close to 360. Do we see that? Okay. We're going to do number 5 or number 7 together because this one's just a little different. All right. So we have 5 and we're multiplying by 180 over pi. Okay. Oh. Yeah, okay. We didn't draw our picture. Let's draw our picture real quick. So, again, pi is 3.14. Do we understand that? So 5 radians is going to be more than that. Yes? Yes, do we understand that? So it's going to be like somewhere in this-ish realm. Okay. So what's 5 times 180? So when we divide by 5, you double it and move.
400?
So when we divide by 5, you double it and move the decimal. When we multiply by 5, you have it and move the decimal. So 900.
So 9. Oh. That's not really says
It's okay. So it's 900 over pi. And this is now in degrees. And sometimes our degrees look like that. That's our degree. This is degrees. Yep. And if you think about it again, pi is roughly 3, so it's about 300 degrees.
Do you know why we do degrees with that little circle? Like, why is that one just like the odd number out?
I do not know. Why don't you guys try number 8 on your own?
What do you think came first, degree for math or degree?
Probably temperature.
I feel like that.
You think math? I don't know.
Is code something? Very hard. I don't know. Probably degree of math. Celsius probably came first. Is 180 divided by 360?
Yes. Did you get that?
Yeah.
Did you get the picture?
Yes.
Okay, cool.
I didn't get the picture, but I got some.
Okay.
I just copied it.
We're drawing an angle. I recorded the lesson, so you may just have to go back and look at that. Yeah.
Is it any easier way to do like an angle, like drawing it, so like just like mid-section? I'm trying to imagine like a clock.
Yeah. So unfortunately, there's not. Do you have a question or you have to go to the bathroom?
Do we have to draw an angle?
Only if it asks you, but we are going to do ones like in 2 minutes where we're drawing the angle. Does that make sense? So the most I can say is literally like, if it helps you, draw a circle. You can draw a circle. and again, semicircle. And if we're working with like 5 pi over 3, each of these needs to be cut in 3s. Does that make sense? So like 3 and 3. So we're literally doing 1, 2, 3, 4, 5. So this is our angle. Yes. Does that make a little more sense? Okay. I mean, this will take you longer, but if you need that visual, then do this. You'll just cut it into however many sections are like on the bottom. So like 3 is not bad, but when we do like 12, that can kind of become a lot. Okay, let's go. So next thing we're going to talk about is what we call coterminal angles, right? So the terminal side is when we end, where we end. So coterminal are basically angles that have the same ending spot. Does that make sense? So essentially coterminal angles are when we add or subtract 2 pi. Because again, 2 pi is going all the way around the circle. So let's say our angle is here. Okay, and this angle is pi over 4. Right, again, because it's 1/4 of that semicircle. Do we see that? Yes. Okay. So if our angle is pi over 4, we can get a negative coterminal angle. By taking this and going all the way around the other way. And again, we're going all the way around, so what we've technically just done is we have subtracted 2 pi. So we can solve this by getting common denominators. How could I rewrite 2 pi with a denominator of 4? What would that be? 8 pi over 4. And so our negative coterminal angle would be negative 7 pi over 4. So these angles are essentially like congruent, right? We're getting the same angle. It just, the first one we went clockwise, and the second one we'd go counterclockwise. No, mess that up. First one we went counterclockwise, second one we'd go clockwise. Okay, so we can also have a positive coterminal angle. So again, working with the same angle, the same pi over 4. So we can get a positive coterminal angle by taking this side and making an entire loop in the counterclockwise direction. So this time, instead of subtracting 2 pi, what do you think I'm doing? Adding. So we're adding 2 pi, which again would be 8 pi over 4. So a positive coterminal angle would be 9 pi over 4. Yeah. Yes. I'm getting a common denominator there. So I'm just multiplying the 2 by 4. Because also if you like think about it, 8 pi over 4, if I did simplify that, that is 2 pi. So when we're talking coterminal angles, we add or subtract 2 pi, essentially. And it just means that we're making another loop around the graph. Does that make sense? Okay. All right. So this wants us to find, for 2 pi over 9, a positive coterminal angle and a negative coterminal angle. So we're going to, in order to find a positive, what should I do? Add 2 pi. Okay. But again, I need to get a common denominator. So my denominator is going to need to be 9 So what would my new numerator be? 18. So it'd be 18 pi over 9. So a positive coterminal angle would be 20 pi over 9. Okay. Now that is not your only possible answer, okay? So you could actually continue to do this. So let's say we had 20 pi over 9 and I wanted to find a different positive coterminal angle. I would just add 2 pi again. So another option of a positive coterminal angle would be 38 pi over 9. And you could keep going. Also, sometimes when you add 2 pi the first time, it may not get you to a positive coterminal angle. So you need to keep adding 2 pi until you get to something positive. Does that make sense? Hello? Yes? Okay, maybe I'll let you write and I'll say it again. Okay. So like, let's say I had an angle and I added 2 pi and I was still at, I don't know, negative pi over 3. Is that an okay answer for this question? No, I'd have to add 2 pi again until I get something positive. All right, so for a negative coterminal angle, what do we think we need to do? Subtract 2 pi. So that would be negative 16 pi over 9. Alrighty. We got one more thing we got to learn. And that is called the reference angle. And so the reference angle is an acute angle. We call it theta prime. So we draw it with like a little tick mark. We call it theta prime. And it's formed by the terminal side and the x-axis. Alrighty. So we have 4 quadrants of our graph. Quadrant 1, the theta prime is just theta. Like, it is the angle itself. Does that make sense? Yes, no, hello. Chloe, put your phone away. So quadrant 2, again, this is our initial side. If our terminal side is somewhere in quadrant 2, anywhere, it can be here, okay, then that means that our theta is going this direction, right? But what our reference angle is it is the shortest distance between that terminal side and the x-axis. So that means our reference angle would be here, and that is what we call theta prime. Okay. So in quadrant 2, the formula for this, if you prefer a formula, you would be doing pi minus that theta. I'm not going to worry too much about the formula because we're kind of just going to count like what would it take to get us to pi. In quadrant 3, again, if I have an initial side here and a terminal side somewhere over here, all the way around is our theta. But again, our theta prime is just the closest x-axis. So this is our theta prime, our reference angle. So in this quadrant, our theta prime is theta minus pi. And in our last one, our quadrant 4, again, our theta would be going all the way around, but we want our theta prime to be to the closest x-axis. So for this one, we would do 2 pi minus theta. Already. Can I go? All right. So we're here. We want to sketch the reference angle. So 13 pi over 4, do we see how that's bigger than 2 pi? Yes. So to make our lives easier when we're sketching this, we want to get it somewhere between 0 and 2 pi. And again, so the way we can do that is we can find a coterminal angle. So I'm going to take that 13 pi over 4, and I'm going to subtract 2 pi to get something a little smaller. So how can I rewrite 2 pi? 8 pi over 4, right? And so that's going to give us 5 pi over 4. Do we see how that's now between 0 and 2 pi? Yes. Because I'm multiplying 2 by 4 to get a common denominator. So that's like 8 over 4 would be 2 pi. Does that make sense? Okay. So 5 pi over 4 is a semicircle. Yes, because pi is a semicircle. And then another fourth. Do we understand that? So it asked us to sketch the angle, so I'm going to draw a little axis. So again, this is pi, and then we got to go another fourth. So it's going to be here. And that is our theta. Okay, right, this is pi. Now our reference angle, again, is going to be from the closest x-axis to that terminal side. Do we see that? What do we think that is? It's 1/4, right? 1/4 of the semicircle. So our reference angle, our theta prime, is pi over 4. Okay. You can also get that by doing the equation, but let's be honest, are you going to memorize all of these equations? Probably not. So that's why I think it's easier to kind of draw it and then go from there. Okay, so the next one, again, is it between 0 and 2 pi? No, because it's negative. So what can I do to make my life a little easier? Add 2 pi, right, to get something positive. So we're allowed to always do that. I mean, you can work with negative 11 pi over 6, but it's a little easier to add 2 pi. So we'll take negative 11 pi over 6, and we'll add 2 pi. So how can I rewrite that? 12 pi over 6. And so that will just give us pi over 6. So again, if we're sketching, that's going to be 1/6 of the semicircle. Does that make sense? So it'd be like here-ish. And because it's in the first quadrant, our theta and our theta prime are actually the same thing. So theta prime would be pi over 6. All right, we got one more. Now, 8 pi over 5 is between 0 and 2 pi. Do we see that? Okay, so we can go ahead and sketch it. So 5 pi over 5 would get us to the semicircle, right? But then we still have 3 pi over 5 more. Does that make sense? Is that going to be more or less than another half? Oh, I'm sorry. What's up?
So, I know I nodded, I was just not what do you mean between 2 pi and 0? Like, why did 8 pi over 5 do that, but not 13 pi?
Yeah. So 8 divided by 5 is a little less than 2.
Oh, okay.
Does that make sense? But 13 divided by 4 is bigger than 2. So that's why we want to get it like between 0 and 2 pi. Because otherwise it's going to like look like a spiral and it'll get real crazy. Okay? So we have 8 pi over 5. This is 5 pi over 5. Does that make sense? Yes? So we got to go another 3/5. Is that more or less than another half of a semicircle? More. A semicircle would be like 2.5, or half of it would be 2.5. Did we understand that? So we're going a little more. So we're going like here. Okay. But our reference angle, again, is going to be from that closest x-axis. So if we went all the way around, we went to 8 pi over 5, how much more would we have to go to make it to that entire semicircle? 2 pi over 5, right? We'd have to go another 2/5. Does that make sense? Mm-hmm. So our theta prime would be 2 pi over 5. Again, you can use those equations, but I think it's more complicated. You could just draw it and think about the fractions. Alrighty, you got the rest of the class to work on your homework.